Okay, we're going to do the vocabulary for section 4.5, starting with simple and compound interest. P represents the principal, which is the initial deposit, or the base amount of a loan. R is going to be the variable to represent interest rate. It's given as a percentage per year, and we usually write it in decimal form. T is the variable for time. It's always represented in years. A represents the accumulated value. That means the total amount, whether it's accumulated amount for the deposits or the total amount due if it's a loan. And I is the letter we'll use for simple interest. And the amount of interest is computed only once during the lifetime of the investment or the lifetime of the loan. So if we're doing simple interest, if P is the principal is deposited or borrowed at an interest rate of some kind of percent R for a period of T years, the simple interest account is I equals P times R times T. The total amount is either the amount that you have accumulated from your deposits or the amount that's due for a loan is the total amount of what you put in plus the amount of interest. So P is the amount that you put in and PRT is the interest that they add to it. Another thing is if you notice the P is common to both of those, that would be the total amount is equals P times the quantity of 1 plus RT. We'll skip these examples and we'll move to compounded interest. And compounded interest is interest paid on previously accumulated interest. Basically, you're getting interest upon interest. So if you're compounding yearly or annually, that happens one time a year. Semi-annually is twice a year. Quarterly is 4 times a year. Monthly, there's 12 of those in a year. Weekly is 52 times a year. And daily would be 365 times a year. So if we're doing a compounded interest formula, the principal is P. It's deposited as an interest rate of R. It's compounded N times per year for a period of however many years you leave it in the account. So the accumulated value is the principal times the quantity of 100% of your money is the 1 plus the interest rate over how many times they compound it, so a part of that interest rate for depending on how much of the time you're spending on it, raised to the power of NT. And we're going to move on to the next section and do the examples in class. Interest compounded continuously. That means you're going to compound it as fast as you possibly can. So when you're compounding for N periods and it becomes very, very large, you compound it as fast as you can. R over N, as this N is getting very large, that whole fraction is getting very, very small. And that's why the exponent NT is also getting very large. And A, the amount that you have, either that you have in the account or that you're due for a loan, is also getting larger. It'll level out toward the letter E. So the principal P is deposited at an interest rate of R, is compounded continuously for a period of T years, is represented by the total amount is equal to P times E to the RT. I call that the PERT equation. If we go down to annuities and amortization, this happens when instead of just putting money into an account and letting it sit there and just wait until the interest accumulates, this is where you plan on putting money in every single month and keep adding to it, or every single week, or whatever scheduled amount you want. So an investment plan involving regularly scheduled deposits over the life of the investment. So this is where you keep changing it by adding more and more money to it. So the periodic payment is P. It's deposited N times per year at an annual interest rate of R, with the interest compounded N times per year for a period of T years. And the equation is given by this. And this R, for the value of the rate, is the rate divided by how many times you're going to compound it. And the total amount, that A, is also referred to as the future value. If you took any business classes in the future, you'll be discussing future value of any of the accounts you'll be working with. And we'll move on to the last section, which is exponential growth and decay. In growth and decay, Q we're going to call the quantity, the amount after it starts growing exponentially. Q sub 0, that subscript means the initial amount, the amount before any growth or decay happens. R we're going to use for the variable for rate, whether it be a growth rate or a decay rate, if I can spell. And T represents time. So this is exponential growth, and this is exponential decay. Notice that the only thing different in these is going to be this little negative RT for the exponent, which means it's like a 1 over E, which makes it a fraction for that initial, or the B value. If we go down a little bit more, if we're dealing with radioactive rate or decay, if H represents the half-life of a radioactive substance per unit of time, the nominal rate of decay per unit of time is given by R equals natural log of 2 over H. And we'll do examples in class on all of these different types of formulas.